Assalamu alaikum students. In the previous lecture, we discussed what is multiple linear regression and how to derive the intercept in multiple linear regression. So in this video, I will show you how to derive the partial slope coefficients in multiple linear regression. So remember that this is our sample regression function in k variable case. We can also write this sample regression function in two variable case where y equals beta naught hat plus beta 1 hat x1 plus beta 2 hat x2 plus u hat, where u hat is our residual. We can write this sample regression function in the deviation form. Remember that this sample regression function is in the actual form. It is in the raw form because we do not do any transformation on this equation. So when I make transformation it into the deviation form, we get the deviated form of sample regression function, which can be written as small y equals beta 1 hat small x1 plus beta 2 hat small x2 plus u hat. Here small y is the deviation form of y variable, which is equal to y minus y bar. x1 is the deviated form of x1 variable, which is equal to x1 minus x bar, and small x2 is the deviated form of x2 variable, which is equal to x2 minus x bar. Remember that these small alphabets show the deviated forms of each variable. Remember that deviation means the spread of the variable around its mean. We can also write this SRF in this form: small y hat equals beta 1 hat x1 plus beta 2 hat x2. Here you can see that the residual equals y minus y hat. So when substituting the value of y hat, we get this equation. Remember that this is the deviated form of sample regression function, which comes from this equation. You can see that here there is no intercept, there is no beta naught hat, because in deviated form of regression there is no intercept. I showed it you earlier in the previous lectures that when we write the regression equation in deviated form, there is no intercept because it is cancelled out. So the intercept is 0. Therefore, I have not written the intercept in this equation. So u hat is the residual, which is the difference between y minus y hat. I have substituted the values of y hat here. The y hat equals this equation. So when I open the bracket, I get the answer of u hat, which is equals this term. So when I sum and square the residual, I get this equation. This is the sum of square residual, which we are going to minimize. So I take the partial derivative of this equation first with respect to beta 1 hat, then with respect to beta 2 hat, then set it equal to 0. Why? Because our purpose is to find the values of these two unknown parameters. Beta 1 hat and beta 2 hat are our unknown parameters, and we want to find their formulas or their values. So by taking the partial derivative with respect to beta 1 hat and set it equal to 0, I get the answer as sum of x1y equals beta 1 hat sum of x1 square plus beta 2 hat sum of x1 x2. This is our normal equation 1. You can verify it by solving yourself. I have applied the generalized power function rule here to take its partial derivative. Remember that these x and y variables are in the deviation form. From now, all the variables will be in the deviation form, no variable will be in the actual form. So x1 y and x2 are all in the deviated form. Now we will take the partial derivative of sum of square residual with respect to beta 2 hat and then set it equal to 0. When I applied the generalized power function rule, I get this equation. Sum of x2y equals beta 1 hat sum of x1 x2 plus beta 2 hat sum of x2 squared. This is our normal equation 2. You can also verify this equation by taking the partial derivative of this with respect to beta 1 hat and set it equal to 0. Verify it yourself. Now we have two normal equations, one for each unknown parameter, say beta 1 hat and beta 2 hat. So the first normal equation is for beta 1 hat and second normal equation is for beta 2 hat. Look at this. This is our simultaneous equation system. This is our simultaneous equation model. Why? Because you can see that we have two unknown parameters and two equations. So the system is satisfied. So we can solve this system by using the simultaneous equation methods. So we can solve these simultaneous equations either by using the matrix method or by elimination method or by any other method, but I will use the elimination method because it is the simplest and shortest method. So what this elimination method do? Elimination method eliminates one of the parameters by equating the terms and then find the value of other parameter. For example, in order to find the value of beta 1 hat, we must eliminate beta 2 hat. To eliminate beta 2 hat, we must know that these two terms must be equal. These two terms must be equal. So to equate these terms, we must multiply this whole equation by sum of x square and this whole equation by sum of x1 x2, because in this equation there is no sum of x2 square and in this equation there is no sum of x1 x2. That's why I multiply this whole equation by this term only and this whole equation by sum of x1 x2. Okay, so and then I subtract the normal equation 2 from normal equation 1. So multiply this whole equation by sum of x1 x2, multiply this whole equation by sum of x2 square and then subtract normal equation 2 from normal equation 1. So when I subtract it, I get the formula for beta 1 hat. You can do this by yourself and can verify that by solving this for beta 1 hat you will get this answer. So remember that in this beta 1 hat formula, all the x1, x2 and y variables are in the deviated form. Beta 1 hat equals sum of small x1 small y times sum of small x2 square minus sum of small x2 small y multiplied by sum of small x1 x2 divided by sum of small x1 square sum of small x2 square minus sum of small x1 x2 whole square. Remember, this is whole square of sum of x1 x2. So these all in this formula all the variables are in the deviated form. This is the formula for beta 1 hat. Now to solve the system for beta 2 hat, we must eliminate beta 1 hat. To eliminate beta 1 hat, these two terms must be equal. When these terms are equal, this term will be equal if I multiply this equation by sum of x1 x2 and multiply this equation by sum of x1 square. So I do it here. I multiplied the normal equation 1 with sum of x1 x2 and normal equation 2 with sum of x1 squared, and then I subtract equation 1 from equation 2, so I get the answer for beta 2 hat, which is equal to this expression. So sum of x2y times sum of x1 square minus sum of x1y times sum of x1 x2 divided by sum of x1 square sum of x2 square minus sum of x1 x2 whole squared. Remember that in this formula x1 x2 and y are all in the derivative form. So this is the formula for beta 2 hat. Remember that the denominator for beta 1 hat and beta 2 hat are the same. You can see here, this is the denominator for beta 1 hat and this is the denominator for beta 2 hat. These are the same. Next, this term are also same. Sum of x1 x2, sum of x1 x2 are also same. Only the difference is these three terms. Here you can see sum of x1y appears, and here sum of x2y appears. Here sum of x2 square, here sum of x1 square, here sum of x2y, here sum of x1y. So there is cross relation while the rest of the terms are the same. So it is easy to remember these formulas. You only have to remember one of the formulas. Either remember beta 1 hat or remember beta 2 hat. If you remember one of these formulas, the other formula automatically be remembered. So remember these formulas and do not forget them. This is our intercept in the two independent variable case that I have derived uh, in the part 1 of this series, where beta naught hat equals y bar minus beta 1 hat x1 bar minus beta 2 hat x2 bar. So if you try to solve the numerical problem of multiple linear regression into x variable case, it is more time consuming to make the columns of small x1, then small x2, then small y, then small x1 square, then small x2 square, then small x1 x2. So it is a very lengthy process. So I have written some equations for these terms which are easier to compute by hand. So there are 6 terms that are appeared in these two formulas. So these terms are equal to these terms, and these terms are easier to compute. You do not need to convert the actual variables into deviated form. So the sum of small x1y equals sum of actual x1y minus sum of x1 xy over n. Remember that these terms are in the deviated form, but these terms are in the actual form. So if you remember these formulas, you do not need to compute these deviated forms. So take a screenshot of these formulas and then fit these formulas or equations in the formulas of beta 1 hat and beta 2 hat, you will get the answer easily. Moreover, you can compute these terms easily using the calculator. It is difficult to compute the deviated form in the calculator, but it is much easier to calculate these actual uh, terms in the calculator. In the next video, I will show you how to find numerical values of regression coefficients in the multiple linear regression model using the calculator. I will use this formula, and these terms will be can be found by solving these terms. So once we found the beta 1 hat and beta 2 hat, we can easily found their standard errors and the multiple r square. If you like the video, then share it, and thank you for this video, for watching this video.